An LFU cache has a fixed capacity. When you get a key, you return its value or -1 if it is not there, and if it exists you increment its frequency. When you put a key and value, you update and increment frequency if it exists, otherwise if the cache is full you evict the least frequently used item, and on a tie, the least recently used among them, then add the new one with frequency 1. The goal is to implement both operations in constant average time. We need to find and update items by key in constant time, and we need to know which item has the lowest frequency so we can evict it when the cache is full. When frequencies tie, we evict the least recently used among them. Use a hash map from key to node, where the node holds key, value, and frequency. Use a second structure, for each frequency, keep a doubly linked list of nodes with that frequency buckets. Within a bucket we keep LRU order so when we evict from the minimum frequency bucket we remove the least recently used in that bucket. Maintain the current minimum frequency so we know which bucket to evict from. On get, remove the node from its current frequency bucket, increment frequency, add to the frequency +1 bucket. On put when the cache is full, evict from the min_frequency bucket, tail of that list, then add the new node with frequency 1. We have a map from key to node, where each node holds key, value, frequency, previous, and next. We have a second map from frequency to a doubly linked list of nodes with that frequency, each list has sentinel head and tail. Within a bucket we add to head for most recent and evict from tail for least recent. We maintain min_frequency, the smallest frequency that has any node, so we always evict from frequency _to list, min_frequency. For get, if the key is not in the map return -1. Otherwise remove the node from its current frequency bucket, increment its frequency, add it to the new frequency bucket at the head. If the old bucket is now empty and was min_frequency, update min_frequency. Return the node's value. For put, if the key is in the map, update the value and do the same as get, remove from bucket, increment frequency, add to new bucket. Otherwise if the cache is full, evict the tail of the min_frequency bucket and remove that key from the map. Then create a new node with key, value, and frequency 1, add it to frequency _to list, 1, at head, and put it in the map. Set min_frequency to 1 when needed. Capacity 2. We start with an empty cache. No frequency buckets yet, min_frequency is 0, the map is empty. Put 1,1. We add a new node with key 1, value 1, and frequency 1. It goes in the frequency 1 bucket. The map maps key 1 to this node. Min_frequency is 1. Put 2,2. We add a new node with key 2, value 2, frequency 1. Both keys are in the frequency 1 bucket. Within the bucket, key 2 is more recent and key 1 is least recent. Min_frequency is still 1. Get 1. We look up key 1 in the map and find the node. We return the value 1 and increment its frequency. We remove the node from the frequency 1 bucket and add it to the frequency 2 bucket. Now key 1 has frequency 2, key 2 still has frequency 1. Min_frequency stays 1. Put 3,3. The cache is full. We evict the least frequently used item. Key 2 has frequency 1, the same as the minimum, and within the frequency 1 bucket key 2 is the least recently used, so we evict key 2. We remove its node and add the new node for key 3 with frequency 1. Get 2. Key 2 is not in the map, we evicted it. We return -1. Get 3. We find key 3 in the map, return the value 3, and increment its frequency. We remove the node from the frequency 1 bucket and add it to the frequency 2 bucket. The frequency 1 bucket is now empty, so min_frequency becomes 2. Both get and put are constant time. We look up in the map, remove a node from one frequency bucket and add it to another, and at most evict one entry from the min_frequency bucket. Space is linear in capacity, the map and the frequency buckets together hold at most capacity entries. The LFU cache class stores capacity, a map from key to node, a map from frequency to doubly linked list, min_frequency, and size. The constructor initializes all of these. Get looks up the key in the map, if missing return -1. Otherwise remove the node from its current frequency bucket, increment its frequency, add it to the new bucket at the head, update min_frequency if needed, and return the value. Put, if the key exists, update its value and do the same as get, remove from bucket, increment frequency, add to new bucket, then return. Otherwise if the cache is full, evict the tail of the min_frequency bucket and remove that key from the map. Then create a new node with frequency 1, add it to the frequency 1 bucket, put it in the map, and set min_frequency to 1 if needed. Remove from list unlinks the node from its current frequency DLL by wiring previous and next. Add to frequency list ensures that frequencies DLL exists, then inserts the node after the head so it becomes most recent in that bucket.